The topic that we are going to cover today is particle physics. So first of all, we need to define a fundamental particle. Now let's define a fundamental particle. A fundamental particle is the particle that cannot be further subdivided, and it has no internal structures. So a particle that cannot be further subdivided and it has no internal structures is called a fundamental particle. So if we are unable to break some particle, then it will be treated as a fundamental particle. Let's suppose out of electron, proton, and neutron. Electron is fundamental. Electron is fundamental as it cannot be further subdivided, and it has no internal structures. So electron is a fundamental particle. The reason being it cannot be further subdivided and it has no internal structures. So a fundamental particle is the particle that cannot be further subdivided and it has no further internal structures. So such particle is called a fundamental particle. Now we are done with defining a fundamental particle. Electron is fundamental. Why it is fundamental? Because it cannot be further subdivided and it has no internal structures. While if we discuss protons and protons and neutrons, protons and neutrons are not fundamental. Protons and neutrons are not fundamental as they cannot be further broken down, as we cannot further break them down, and they have no internal structures. No. In fact, are not fundamental as they can be broken down. In fact, you can break them down. Sorry about that. So protons and neutrons are not fundamental as they can be broken down, and obviously you can define their internal structures. So basically, protons and neutrons are not fundamental, but electrons are fundamental. And one thing you must know that if protons and neutrons are broken down, then a fundamental particle quark is formed. Breaking breaking a proton, breaking a proton, breaking a proton or a neutron gives fundamental fundamental particles called quarks. So when we break protons and neutrons, it gives fundamental particles which are called quarks. So basically what we need to go through is that if we break a proton, it gives three quarks. Breaking a proton gives three fundamental particles called quarks, and same is for a neutron. If you break a neutron, breaking a neutron also gives three fundamental particles which are called quark as well. Three quarks are found. So when you break a proton or you break a neutron, the outcome is three quarks. Now let's go with types of particles. Types of particles. Before discussing the types of particles, we need to understand what is the basis of classification of particles. Particles, particles are classified. Particles are classified on the basis of forces in nature that they can experience. So if you want to classify the particles, then you have to understand which of the following forces in nature they can experience. The common forces in nature are: number one, gravitational, gravitational force. Gravitational force is basically it's a weak force, a weak, it's a weak force that can act over long distances. It is a force of long range. So this is gravitational force. Then the second force that we are doing or discussing is the electromagnetic force. Electromagnetic force is a very strong force is a very strong force of very short range or distance. So electromagnetic force acts over a very short range or distance. It cannot act on a very long range. Then the third force in nature is strong nuclear force. Strong nuclear force keeps neutrons and protons intact or bind together inside the nucleus. So it is also called binding force in the inside the nucleus. So strong nuclear force, strong nuclear force. What are you doing? Oh, yeah, this is wrong. आपने मेरा पेज खराब कर दिया ना. आप तो समझ गए थे कि it's bad. और चले गए. देख लो फिर, you are not my good daughter. नहीं तो ऐसे कौन करता है? मैं तो बच्चों को पढ़ा रहा हूँ ना, आपने बीच में ऐसे कर दिया. स्ट्रॉन्ग न्यूक्लियर फोर्स. सूर्या, मुझसे नाराज हो रही हो? आपने बीच में अजीब से जो ज़ॉम्बीज हैं वो खोल दिए अपने यूट्यूब पे, जो आपने खोले होते हैं. अच्छा, स्ट्रॉन्ग न्यूक्लियर फोर्स should say that is a very, it is the strongest force acting over the shortest range. You should say it is the strongest is the strongest force that can act on the shortest range. So this is strong nuclear force. Strong nuclear force is the strongest force that can act over the shortest range. Then we have weak nuclear force. Weak nuclear force is basically a weak nuclear force is basically it is formed when some nuclear it is formed when some nuclear reaction occurs. So a weak nuclear force is formed at the time of occurrence of a nuclear reaction. So this is the weak nuclear force. So these are the four forces in the nature and their types and everything. Now let's move towards, these are four forces in nature. Now the next thing is how you classify the particles on the basis of these forces. There are two, but I should clear this. This is not about fundamental particles, generally classification of particles. There are two major types. There are two major types of particles. Number one, hadrons. Number two, leptons. So there are two major types of particles. One of them is hadrons and the second type is leptons. Now what are hadrons? Hadrons are the ones which can experience strong nuclear force. Hadrons can experience strong nuclear force and they are not fundamental. They're not fundamental. They are made of other fundamental particles called quarks. And one thing should be clear, if you get a combination of a quark and some anti-quark, if you get a combination of a quark with with some other anti-quark, for example, if you get a combination of two quarks and one of them is anti-quark, basically you should remember if two quarks combine, an anti-quark is also a quark, then it gives mesons. And if you get a combination of three quarks, then you get a hadron. One thing is that the hadrons are not the mesons. Sorry, if you get a combination of three quarks, it is called baryons. It is called baryons. So, but mesons are not in our syllabus. So, if you have a particle in which you get two quarks, this line shows anti-quark, then the particle is called a meson. And if you get a particle in which there are further three quarks, particle is called baryon. Baryons and mesons are collectively called hadrons. Baryons and mesons are collectively called hadrons. Now, this was all about the particles which are called hadrons. The other type of particles are called leptons. So examples of hadrons. Hadrons are, for example, common hadrons are protons and neutrons. So protons and neutrons are common examples of hadrons. Leptons, basically they are the fundamental particles which cannot experience the strong nuclear force. That's why they are not part of the nucleus. So electrons are the fundamental particles which cannot experience the strong nuclear force. So two important things about electrons are they are fundamental and they cannot experience strong nuclear force. However, they can experience all the other three forces in nature. Electrons are the fundamental particles. They cannot experience a strong nuclear force. However, they can experience all the other three forces in the nature. So this is the main lesson about electrons. Now, if we look at a picture of particles in overall, then we go with, first of all, what are the fundamental particles? There are two fundamental particles, as you know. They are fundamental particles could be electrons, or fundamental particles could be, second type is quarks. Two types of fundamental particles are electrons and quarks. About electrons, you should say that they are fundamental. They are fundamental and they cannot. They are fundamental and they cannot experience. They are fundamental and they cannot experience the strong nuclear force. So electrons are the fundamental particles and they cannot experience the strong nuclear force. What about quarks? And one more thing, they have they have independent existence. So we can say that they can exist independently. They can exist independently. Now, what about quarks? Quarks are they are they are fundamental. They are fundamental particles which which do not exist independently. Which cannot exist independently, but combine combine to combine to make hadrons. So quarks are the fundamental particles which do not exist independently, but they combine to make other particles which are called hadrons. And if you get a combination of two quarks, a quark combines with its antiquark, it will give you a meson. And if you get other situation in which three quarks combine, then it will give you a baryon. Combination of three quarks give you a baryon, and a combination of two quarks give you a meson. So this is the situation which we have to understand. There are two types of fundamental particles. They are either electrons, they are either quarks. So electrons are the fundamental particles which do not further combine, while quarks further combine to make hadrons. And there are two types of hadrons. One of them is mesons. Mesons are not in our syllabus. Baryons are in our syllabus, and collectively they are called, obviously, they are hadrons. Now, let's list properties of electrons. List of electrons. It will go like, first of all, you will name the electron. You will write the name of the electron, then you will write its name of the electron, then you will write its electron number. First you will write name of the electron, then you will write the electron number, then you will write the second you should write the symbol, not the electron number, but go with symbol at the second position. So write the name of the electron, then in the next column you need to write the symbol for that electron. Then after writing the symbol, you need to write the charge on the electron, and then you need to write the electron number. Now let's start. First of all, the first electron is electron. Second electron is glucon. Third electron is tau. There are three charged electrons and there are three neutrinos. Neutrinos are neutral electrons. Then we have electron. Then we have electron neutrino. Then we have electron neutrino. Then we have muon. Then we have muon neutrino. Then we have tau neutrinos. So these are the neutrinos. If we fill this table, first of all, symbol for electron is E, charge for electron is -1e, and electron number of all the electrons is irrespective of their name or anything, it is +1. What is electron number? This is the property that is used to count the electrons in a nuclear reaction. So basically electron numbers are used to check the conservation of electrons by principle. For a nuclear reaction, the electrons on the reactant side and the electrons on the product side must be equal. Now, symbol for muon is mu. Symbol for tau is tau. Tau is a Greek letter. This is symbol for, we write it like T and the line is a bit different. This is symbol for like tau. Electron neutrino Ve, neon neutrino V mu, tau neutrino V tau. Now their charges are -1e, -1e, and these three electrons have no charge at all. Their charges are 0. So electron number of all the electrons is +1, and the neutrinos have no electron. Their charge is 0. Electron number for all of them is +1, while for neutrinos the charge is 0, while for the simple electrons the charge is -1. This was a list of electrons. Now let's write a list of anti-electrons. A list of anti-electrons. Now you should write the name of anti-electron, then you should give its symbol, then you should give its charge, then you should give its electron number. So this is a list for electrons in general. Anti-electrons are number 1, anti-electron, number 2, anti-muon, number 3, anti-tau. Number 4, anti-electron neutrino. Number 5, anti-tau neutrino. Number 6, here the order is not important. You need to list the 6 anti-electrons. Anti-muon, anti-muon neutrino. Now let's fill the symbols and other properties. Anti-electron symbol is this one. Anti-muon symbol is this one. Anti-tau symbol is this one. Anti-electron neutrino symbol is this one. Anti-tau neutrino symbol is this one. Anti-muon neutrino symbol is this one. And the charges are, here we have -1e, here we have it is +1e because it is anti-electron. Anti-electron has a positive charge. Symbol for anti-electron is charge +1e. For anti-muon +1e, for anti-tau it is +1e. So these are the charges. And for neutral electrons it is 0. Electron number of all the electrons is -1. Irrespective of their name or anything, all the electrons have electron number of -1. And one thing, electron basically a beam of electrons is also called a beam of electrons is also called a beam of negative beta particles. So beta particles negative are generally electrons. So beta, so you must know that beta negative is actually electron. The symbol for beta negative is beta -1, 0. And we also have positive beta particle, that is +0. Beta positive is anti-electron. So electron is beta negative and anti-electron is beta positive. So this is the whole story for the fundamental particles in a matter. So we have listed leptons and anti-electrons and all of that. In the next lecture, we cover quarks, composition of protons and neutrons, and standard nuclear reactions. So this lecture or slide is up to this point. In the next lecture, we'll cover quarks and onwards. Take care, students. Khuda Hafiz.